Are filling in just this little sentence down at the bottom. Do I have an eraser? Yep.
Everybody makes mistakes, so
Okay. You can just start copying. I'm going to talk about this in a minute. Ian.
B+. Pretty good. Yeah? Hard.
Did you get a 39 out of 44?
I got a 39.5 out of 44.
Hey, we're going up.
Hell
We're
yeah.
so up.
Wait, Miss Nolan, do you use our class for recordings?
I got a 30.
That's pretty cool.
Yeah, which means I can hear all the things you say.
Hard.
What? No, just this one.
These two, I'm always looking for something cool.
Because we always move at a good pace in this room.
Shut up, man. There's been 4 contracts. Shut up.
Okay. So as you finish writing, just stop talking. I'm going to talk through what this means. Okay, so the box at the top, okay, the fundamental theorem of algebra. We've finally arrived. After how many weeks we've reached the fundamental theorem, okay? So I'll scroll back down. So if you didn't finish copying, you'll get there. You'll get to see it again. Okay, so if f of x is a polynomial degree of n, where n is greater than 0, meaning we don't have just a constant term, that's just telling me I do have a variable present, then f has at least 1 0, meaning it's going to cross my x-axis somewhere in the complex system. Okay, complex, where have we heard that before? What does that tell me? That we're dealing with what kind of numbers now? What does complex tell me? Hard numbers, yeah, they're definitely hard numbers. They could be square roots. There's a specific kind of number. Irrational, okay, this is an irrational number. I'm thinking of an irrational one, yeah. Imaginary. Okay, so today we're going to see some imaginary numbers again. So in the complex system just tells me that imaginary numbers are now in play. Okay? All right, linear factorization theorem. If f of x is a polynomial degree of n, where n is greater than 0, then f of x has precisely n linear factors. That word precisely just means exactly. Okay, so on the last chapter, we used our exponents and it told us we had at most a certain number of turning points. This is even stronger of a theorem. And all it tells me is that leading coefficient, whatever its exponent is the exact number of zeros we'll have. Okay? Now, that little asterisk that I put down there is important because I'm just specifying that this theorem tells me how many of them exist. It doesn't tell me what they are or how to find them. Okay? So, for example, number 1 here, if I give you y, we agree y is just f of x, okay? Just a different way of writing it. Equals x minus 2. That exponent up there was a 1. So that tells me I have exactly 1 0. Or one spot where it's going to cross the x-axis, okay? So I know this seems simple, but just to make sure we really understand what's happening, that's going to be a key for today. Not just knowing how to do it, but understanding what the heck we're doing. We plug a 0 in. My x value here, or my 0, would be x equals 2. Only one of them. One answer would work for that. Number 2 shows me an example where my leading term has an n exponent 2, telling me I have 2 zeros. So if we were to actually solve this, we plug that 0 in for y. This is one that I would factor. It's going to factor like this. Okay. I did that fast, but that's just a review on how to factor. So I have what appears like only one value for x, but we talked about last chapter that we have to think about multiplicity. So this x would happen twice, multiplicity of 2. Hence, my rule of 2 zeros still applies because it has the multiplicity of 2. Okay?
Wait, so.
Yeah.
What's the difference if it has a multiplicity of 2?
That just means that it technically hits that 0 2 times. We won't see that happen on the graph. Like visually, we can't see that, but that's what's happening.
Do we have to write that?
No, I'm just showing you the multiplicity of 2 proves that I have 2 zeros, even though I only have one number of 3. Okay, it happens twice. Good question. Okay, number 3. Again, if we were to actually solve this one, if you haven't written down how I'm solving all the other ones, I want you to write this one down, okay? So I plug the 0 in. To simplify this, I got to take out my GCF. So I take out an X. Bless you. And now I've got a couple options for my X values, right? I know that I should have 3 zeros at the end of this. Okay? I know that for a fact. So the first one, nice and easy, X equals 0. The second one's a little harder. You're going to have to solve for it. Why do I know it's not this? Why do I know it's not that? What would this have to be instead for me to factor it like that? You remember? Yeah, it'd have to be a minus sign right here. Okay? That's the only way I can factor it. So don't fall for that trick. Okay? So we have to solve this one by setting it equal to 0. Okay? There is no way to factor this one. So we have to just get x by itself. So I'd subtract 4. I have x squared equals negative 4. I square root both sides. And so here we have our first imaginary number, because I can't take the square root of a negative and have a real solution. If I take the square root of a negative number, I have to incorporate my imaginaries. Okay? Here's where my second 2 zeros come into play. Okay, I've got that plus or minus going on in there. So I have 1, 2, 3 zeros, which shows up out here. Okay? Now on a graph, all you would see is this 0. Okay, because the other one's imaginary. Okay, so on a graph, you only see it cross in one spot. But we know we've got to think about imaginary now. Okay? All right, any questions on this page? Just the concept in general. Yeah, Colin.
What do you mean on a graph?
On a graph, well, let's actually try it. Desmos.
Yeah, how do you do it?
Okay, so x. Oh gosh, I don't know how to do it on here. Oh, there we go. X to the 3, what was it? Can you, oh, you have it. Plus 4x?
Yep.
4x. So we only see it right here. Oh, zoom in. We only see that 1 0. It's the only place we see that it crosses. We don't see the imaginary world. Okay? That goes into like college level calculus as like what's actually happening. But we only see real number zeros. Because these are imaginary, you won't see them with your eyes, but you know they happen. Okay? Just accept that for what it is now. In college, maybe you'll actually go into the proof of it, but we'll see.
I hope I do.
You don't want to? All right. Flip your page over. Okay? The rational zero test is what we're going to focus on today. Okay? So this is a lot of letters and words and exponents and variables. Okay? I'm just going to read it, then I'll actually put an explanation to it. It says, if the polynomial f of x has integer coefficients. So that's the first thing. All right, let's stop our side conversations, please. Integer coefficients. So what does that mean? No decimals, no fractions. Okay? Okay, that's what that means. So all my coefficients are nice numbers, right? That's all that's saying. Every rational zero of f has the form p over q. Okay, so before I go into what that P over Q is talking about, rational zero. Okay, let's talk about what that rational word means. We did this like way back the first day I met you all. Okay, when we're talking about rational, that can include fractions. Shh, guys. That can include fractions, or no, I'm gonna have to zoom in real quick. Terminating decimals, terminating decimals, okay, or repeating decimals. So basically, all this is talking about is if I have a polynomial with all integers, every single rational zero has this form, okay? Now, what is this form? This right here, okay? P over Q. I like the wording last over first, okay? Because we're talking about the last term when it's in standard form and the first term. So the most important thing here is that we need to make sure our polynomial is written in standard form before we can use this theorem. Okay, so we have to make sure it's in standard form. Then we just use this fraction and we do the last term over the first term. The last thing I'm going to say about this before we do a problem is I ignore the symbol in front of my numbers. Okay, so I ignore the symbol, I just look at the number itself. Okay, so you'll never have a negative up here or down here. Okay, it'll always be a positive. Okay. All right. So let's just do our first example. I'm sure it's going to look very familiar to you after we start doing this. Okay, because this was, I think, what you almost ended with in Algebra 2. I could be wrong. I forget what chapter you guys learned this. All right, so here it is. It's in standard form. Okay. I'm going to do my P over Q, or my last over first. So I have 1 over 1. Now, to find my rational zeros, I need to list out my factors of the numerator and my factors of the denominator. Okay? So to get a positive 1, I could multiply 1 times 1 or negative 1 times 1. Okay? So the factors of 1 are just positive and negative 1. The same goes with the bottom. So in other words, the factors of 1 are just 1 and negative 1. Okay, so that's all we've done so far is we've listed out possible zeros. These right here are possible zeros. We don't know that they're for sure zeros. These are just the possible ones. Okay, now like I said before, today is going to be really important in terms of understanding why we're doing something or what we're doing as opposed to just memorizing how we do it. Okay, so I said those are possible zeros. Okay, if something's a 0, that means it crosses at the x-axis. And then we talked about last chapter that if something is a 0, it's also a factor, right? So for example, this 1, if that's a 0, what was its matching binomial? If 1 was the 0, what would its matching binomial be? X what? If it's 1, what would it have to be? Minus 1, right? That would be its matching binomial. What about this one? What would that matching binomial be? X plus 1. Okay? So that's really what we just found. We started with the zeros. Okay, we found the possible ones. If these are the zeros, these would be their matching binomials. Now think back to what we just took our test on yesterday. How do I prove that something is a factor? What would I have to get as a remainder? 0. Okay, so we're going to test each of these, 1 and negative 1, to see if it truly is a 0. Okay, so let's test the first one. Let's test our 1. Okay, testing this guy. We're going to use synthetic because we can, it's easier. Now be careful. I need a placeholder here because I don't have that x squared. Some of us missed that yesterday on our test. That was a lot of what we lost points on. Okay, missing that placeholder of the 0. Okay. All right, so we're testing our first one. I bring it down, we get 1. 1 times 1 gives me 1. I add them, I get a 1. Do another one. 1 times 1 gives me 2. All right, so yeah, Patrick.
So with the P and Q about like the factors,
Mm-hmm.
so if either of the first or the last has a coefficient of 1, those are the only factors in B.
Yeah,
Okay.
yeah. Okay.
So it's only the last one.
So,
Only the last number over the first number. This one worked out to be 1 over 1. That's going to be rare. We're going to have a lot more here in the future. Okay? And I'll show you a little trick to help with that. Okay? All right, so what'd you say?
so like when you're determining the factors,
Mhm.
like say like for this one of the last term, it has to be a common factor. It has to be like the common factor.
No, just do one at a time. So what are my factors of 1? I list them here. What are my factors of the denominator? List them here. So don't think of it as like what are they, like what do they have in common? Don't think it that way. Just do the top and then do the bottom. This one, it works out that they have the same. It won't always be that. Okay? The next one might help. And if I'm not understanding your question, ask it again after our next one when we have different numbers. Okay. So what did we just find here? Is this a 0? No, it's not. So I know I can cross off 1. It's not that. Okay, we don't know for sure that it's -1 yet. Okay, we can't rule it out. We might have an imaginary. So let's test -1 now. Okay, we use the same coefficients. Oh, I forgot my placeholder. Oh, bring down the 1. Where's my notes for this? 'Cause one of these should work.
At least we get to skip some opportunities.
Right. Okay. So it doesn't work, right? So all we found out here is that both of these zeros don't work. Read my directions. Find the rational zeros. Is an imaginary number a rational 0? So all we would write here is no rational zeros. Okay? No rational zeros. Okay? Yeah. All right. Any questions on that one? Just the process. It's going to get a little crazy next one. So ask me now if you have a general question. All right. Let's look at the second one. Okay? We've got a little more going on here. Okay. So right now, at the very beginning, I can expect that I should have exactly how many zeros here? 4. Do I know how many of them are rational? No. Okay, so I don't know that. But I know that the most I could ever get would be 4. Okay? All right, so we start with our P and our Q. P, Q, last over first. My last number is 6. Again, remember, we're disregarding the minus sign in front of it. We just take the number itself over 1. Now I want you to list your factors just for the numerator. So for the numerator, so we disregard that for this. We just look at the number itself, okay? All right, so I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, over plus or minus 1. All we did was list all my factors for the top and then all my factors for the bottom.
Do we need to do this?
Yes. Okay, so now here's where some of you might start to shudder as you think about algebra 2. So right now, look at how many factors we have to pick from. Factors of 6. 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3, and 6 is divisible by 6. Okay, and all of those can be plus or minus. Okay, so here we have, you don't have to write anything, just listen for a second. I could have positive 1 or negative 1, positive 2 or negative 2, positive 3 or negative 3, positive 6 or negative 6. So we have 8 different possible zeros. Now, in Algebra 2, you went through and you had to just guess and check. Do you remember that? You had to do all these synthetic. You maybe got unlucky and you didn't get the right one until the very end. And it sucked. Well, we're going to use our calculator in Algebra 3 to avoid doing guess and check. So, I'm going to do it on Desmos first because it's easier to see. Okay, Desmos is a lot easier. In Schoology, I provided you with a Desmos link so that you could use it, but you will have to use your calculator on a test. Okay? Yeah. Yes. Wait till my pass comes back, actually. Let me get this out. All right. So we've got x to the 4th plus, is it just x cubed, next one? Cubed. Can you tell me what comes next? Plus x squared. Okay, do I have a coefficient on the linear term? Minus 3x in minus 6. Okay. Shh, guys. All right, so here's my graph on Desmos. Okay? I'm going to zoom out even farther. Okay? Now, when I look at this graph, and I zoom in here, this is why Desmos is nicer, is it'll tell you those points. Okay? So it looks like I've got some decimals happening here. Oh, wait, I didn't type it in right. I need a negative right here. Minus.
I think I'm having a heat stroke.
Is it warm in here for you?
I'm sweating. I'm having a heat attack.
Okay, that's better. All right. So once I actually typed in the right equation, if we look on Desmos, look up at the board for a second, we can see, and you'll be able to see on your calculator, that it looks like I have a nice 0 at 2, and I have a nice 0 at negative 1. Okay? So this is what helps us not have to guess and check. Out of all those factors, those two look like they're going to work. Yeah. In a calculator, you'd graph it in your y equals screen, and then hit graph, and you should see it cross in those spots.
O'Reilly.
See what I mean? So you'll just see like, oh, that looks like that's at negative 1.
Wait, really?
Okay. Desmos is nicer because it actually highlights those values for you. Okay, but you can do it. You could do that, but you still have to show me algebraically. Yeah.
I put it in my calculator.
Yep.
But then I speed it.
Oh boy.
For me, it wasn't like on the -1, -2. It was on like the middle.
Oh, my guess is because maybe we. That's okay. Clear your calculator. Hit second plus 712. Sometimes graphs can be like reformatted, and so that might have been your issue. Yeah.
For finding like the X
Yeah. These?
on our calculator,
Yes.
like, are we just supposed to assume what they are? Because it's not going to give it.
It's not going to use that. That's why Desmos is a lot more helpful. But you should, if you zoom in, you could see it closer. And actually, there's a zoom button.
Are there supposed to be 4?
Right, there are supposed to be 4. We're going to get there. Yeah. Can you wait? We got. You're up.
No, you're good now. I got water.
Okay. All right, so let me just summarize what we've done because I just answered a lot of questions. Okay, so we first found that we had all these different possible zeros. Okay, it would have been a nightmare to try to guess and check. Okay, however, using your calculator, we can see that I should have some zeros at 2 and -1. Okay, so those are going to be what I start with. Okay, oh, wrong screen. Okay, so our calculator showed us that we should check -1 and 2. Okay, so those are going to be the zeros now that we use in synthetic. So I'm going to start with -1. So I have 1, -1, 1, -3, and -6. Okay. Make sure in synthetic we actually look at our symbol in front. Even though we ignored it for the PQ, we have to look at my symbols when I plug in my numbers for synthetic. A lot of us missed that on our test too yesterday. We were ignoring some negatives. Okay. All right, so go ahead. I want you to do synthetic on this. And what should we hopefully get at the end? 0. We should hopefully get a remainder of 0. Very nice.
But don't we already know this works?
Right, you do already know this works, but we got to show it algebraically. Your calculator just saved you time by helping you figure out which ones to check. All right, so we get our first one. We got 0. That looks good. Now the second part, okay, this is what most kids mess up on moving forward. Okay, so look up here. We checked this one. We saw that one worked. When we check our second one, okay, I'm going to go to the side. When we check our second one, the numbers that we put up top here for synthetic are the numbers that we got in our final answer from over here, not the original problem. Okay? Again, I'm going to say it one more time. When we check our second one, we use these numbers to do synthetic as opposed to the starting problem. Okay, and we'll see why that's so important later. Okay, so I'm going to take these numbers, and that's what goes up here now. If you don't do that, you're going to be in a world of hurt in the last step of these problems. Okay? All right, so I'm bringing things down. Oh my, what did I do wrong? Oh, I brought the wrong thing down. 1. It's 2. All right, we still should get a 0 if it works. Okay. So all I did was the second synthetic. So up at this point, all that I've proven is that the 2 zeros my graph showed me were actually true. Okay, actually legitimate. I didn't mistype something in my calculator. On your test, don't just tell me -1 and 2 up here and then not show me the synthetic, okay? I do need to see you do it algebraically. That's what I'm assessing you on. Okay, the calculator is just a way to make your life a little easier, okay? All right, so now the last step here, okay? Again, we need to think about what we're doing. What did we just find? Well, we found zeros. So to rewrite these as binomials, that -1 is really x plus 1, right? If I'm thinking about this in terms of factors. Okay, so that -1 is really x plus 1. The 2 is x minus 2. And then this last part, what you found, is my last factor. Okay, so this would be an x squared plus 3. Okay, that's how we would rewrite that final answer. Okay? This right here is why we have to use this set of numbers. Okay? If you had used the top numbers for this second round of synthetic, you would have gotten 0. But you wouldn't have had the simplest binomial as your factor over here, okay? So that's why we have to do the new numbers up here in the second round, okay? All right, we're almost done, okay? So all we've done so far at this step is we've just factored We have factored our polynomial as much as we can. So now let's just actually label our zeros. Okay, again, our zeros are where it crosses the x-axis. So the first one, we already found that, -1. This one's a 2. The last one, again, we can't factor it, so we'd have to set it equal to 0. So we have x squared equals -3. So my last 0 here is x equals plus or minus I square roots of 3. Okay? And that, oh gosh, they went away. There we go. And that makes sense, right? Because at the very beginning of my problem, we said we needed how many zeros? What was my leading exponent? Yeah, 4. Okay? So I needed 4. Okay, so there's 4 total. Now let's go back to my directions. What kind of zeros am I asking you to tell me? The rational ones. Okay, so the only rational ones I have are -1 and 2. Okay, so that would be your final answer. But we still have to go all the way down here because this could have been some nice numbers. They just could have been fractions or something crazy that would have been rational. Okay? All right, that was a lot. Any questions now that we've finished the problem? All right. I want you to try number 3. I've already started it with our first and last. Okay? So there's my fraction. There's all my possible factors. Practice with your calculator. Go find which zeros you think you should try. I'm going to put my last problem on the board here. So if you get stuck, look back up here and use my work to almost act as a model here as you work through this next one. Okay? So steps-wise, here, let me actually write this. So this was our first step. We did that. Our second step, we used our calculator to try to find which zeros to test. Once we found those, we did 1 round of synthetic. Then we did the second round to test the other 0. Last, we put them in their factored forms. And then we found our zeros. Okay, so the blue are the steps that we took, because I know it's a little everywhere. Okay, but go ahead, try this next one on page 3 of your notes. Back to the other one. That?
You go back to the
Yeah, I will. She's just writing this down real quick, then I'll go back. Let me know when I can go back, Sarah. Okay.
I don't understand how you get that.
How you get that first fraction? Our last goes on top. So this last number was on top. This number, the first number was on the bottom. Then we listed out the factors of 3. So basically, what are things that multiply together to give me 3? 1 and 3, that's it. You just have to make sure we account for both positive and negative, those numbers. Same with the 2. Okay? Yeah.
There's one on here that's at like a half.
Right. So that's not necessarily a nice, easy one to test. Only test your nice, easy ones.
Okay.
You'll find that decimal one after you go to solve after your factored form. Oh, so type in your equation. So right there, that looks like it crosses right at 1. So put a 1 down, because we know that should be one that works. This one, it looks like it's half, we don't know that for sure, so we can't necessarily use that. Okay, so don't write that one down, you'll find that one later. Okay, down here. You'll find that one once we get to like this step at the end. Okay, so now let's zoom back out again, because there was another one. Just like, you don't have to second, zoom, and go zoom out.
Another negative.
Alright, so it looks like it crosses a -3. So write down -3. So those are the two numbers now. There might be more sometimes, but right now you just two. Those are the two numbers that you're going to test. Okay? Yeah. These are the factors of 3. So the numbers that when I multiply them together, I'll get 3. Can I do it?
Never forget.
Where you type in like 3 divided by x? Yeah, you can do that.
Yeah.
Mm-hmm. We'll stop there. First, we need a calculator. Okay. Go to your y screen, like your y equals, type in your equation, and then hit graph.
Oh, that's one.
54. All right, let's actually practice this out. Even though it's hard, you're only going to do it by trying. Okay.
And then what do we do?
Yep, we got 3/2. Now, what are my factors of 3? Yep, and make those both positive and negative.
I don't know, do we do that? What do? We do the better stuff?
1 and x are the factors of the dominant.
What do we do with this information?
Okay, good question. Right there, see how it looks like it crosses exactly at -3?
Yeah.
So that looks like that's a pretty good one to test. See number 2 up there? Where I'm listing out the ones I should probably check out? Write that one down, check that one out.
Oh, like -3 is the denominator? Oh, the, I see the multiply, like the, like -3 and then it's like the synthetic.
Yes, that's one you're gonna use. Now pause, before you actually do synthetic, there's another one. Okay, if you ready to hit zoom, hit the zoom button, and then go down and hit zoom in. Yep. And then enter to actually. Okay, so you gotta wait a second for it to actually work.
No, it's at 0.5, it's at 1.
Okay, so we know we have one for sure at once. Put a 1 right there. The other one, you're right. It looks like it's a half, but we don't know that for sure, so we can't write it down yet. You'll figure out what that 0 is at this step right here. When you find like the last one, you'll find that spot you think is a half.
Okay.
Okay? So now use your 2 numbers to do synthetic.
Wait, what's the point of the +1? Oh.
So you got 0. Okay, good. Now, oh, I see, okay, I see. Oh, don't test this decimal, because we don't know for sure.
It's a 0. Oh, this
It
is
looks
good.
like
Oh,
it
this
could be
this
that,
works.
only test nice whole numbers.
Wait, so.
So only test the 1 after that. You'll find that decimal 1 down here when we do this last little step that we didn't try. You'll find what that is like for sure.
-3 and +1.
Those are the only 2 you do with synthetic.
So get the 0.
Nope.
So I-
Yeah, now we do synthetic. So pick one, whichever one you want to do first. Do it with the original coefficient.
Dude, I got it. This
What's
is
going, how do you get that? Wait, what?
It's a
Wait, we get this and then we got it?
So you gotta like do the thing.
Not yet. Do synthetic one more time if you're using these numbers that you found.
Do you keep everything positive?
For factors, like when you list out your factors right here. Oh, yes. Don't do this one. We're doing this one tomorrow because it's awful. So do this one. Yes, Mom.
All right. Where do you find the third parenthesis from?
Right now, what do I do?
Is it 2x? Wait, is it 2x minus?
So you brought the 2 down.
Ooh.
So
Oh,
the
yeah, yeah.
last factor is just.
2x minus 1.
Okay.
So you have this one.
Oh, wait, so like this 2x squared minus the third one.
Yes.
It doesn't give us a fourth, like, random one.
So this one I should only have 3.
Oh, yeah.
Okay? So you found this, so this is good.
It doesn't even have the third one.
No, it
So
will.
it works.
For some reason, it has like
X equals negative 3.
No, it won't give us the fourth one. So now, write your factor, oh, just like this. Now find your zeros. Here are your 2. That should be it, yeah. That's just- Because this is my remainder, my constant, my linear term. That's because we had 3 squared. That would have been like just x, but it was a 0, so we didn't write it, okay?
Oh. This one.
Yeah.
So for the first one.
Oh, do I just? I take all of these out.
So you found these 2 perfect. Now, oh, pause. Can I pause you? When you, so is this the first one you did?
Wait, if you
When you
squared
do the
something,
second
is it
one,
plus or
you have to
minus?
use these numbers. Just because.
Oh,
Okay?
When you square root something, is it always plus or minus?
Yes. All right, I'm going to show us our answer for this one. I tried to color code as best I can, just because it's a lot of math happening. Right now, look at your work, look at mine. We should have 3 zeros. Okay. I've had a lot of people ask me where we get this guy from. Remember, he comes down from the bottom the last time I do synthetic.
Wait, then how
He's the one that comes up here.
how is it x plus 3x minus 1 if that one starts with 2?
If this one starts with 2,
No, the when you do this synthetic with negative 3, it's with 2.
this
It's
one,
gonna be, yeah, if you try to factor that, isn't that 2x squared minus 3x plus 1? And that would be 2x minus 1 times x 1.
we do this one. We use the bottom one, not this one. We don't touch this one again. He's
No,
used to
I
the
got
second one.
confused. I thought, this is not how you see.
I know, it is not
I
easy.
guess I kinda got the answer, but.
Oh, you just put a little square on there that we didn't need.
Oh.
Okay, because this is my constant. That's my remainder. Constant linear term. There is no x squared.
yeah, no,
All right,
I
yes.
bought Eve at Mega Night, because I had enough.
Your bread was good.
These
I got hella
maybe.
bread.
I need to get off the level.
Yeah,
Not necessarily.
I don't even know what to use. Yeah, it's like,
Right. For, again, my not, I'm not talking about my answers. My answers can be correct. Yeah. Okay, the second one on here is a doozy, so we're gonna do it tomorrow. We're gonna skip it, okay, whatever, I don't even think it has a number.
So when you factor this, how do you get,
It's a
if you factor this, how do you get x plus 3 x minus 1 x minus 1?
X plus 3, that comes from up here.
That's this just helps with this, this doesn't help.
Yes, this only helps us with our second round of synthetic. Alright, so like I said, we're gonna do that next one.
Wait, can I take a picture of that real quick?
I want to get really, really cold.
We're gonna do that bottom one tomorrow as like a little warm-up to refresh ourselves in the process. Alright, last little bit. We'll see how far we get. We might have to finish this up when you guys come back in from lunch, okay? Complex zeros occur in conjugate pairs, okay? We've seen all these words before. It's been a minute. But just to make it simpler, all that means is if I have a complex number like this where I've got an I in it, if you have any of those occur as a 0, the opposite also has to be there. So for example, if I tell you, well, I'm about to do that one. If I tell you that 4i is a 0, you know negative 4i also has to be there. Okay, you can't have one without the other, like a package deal.
You just put a plus minus.
That's exactly why that rule works. Okay, because when you do the square root, we get that plus minus. Okay, so now for these next 2 examples, we're going backwards. So I'm giving you the zeros here. Okay, so I'm telling you in this one that I have a -1, a -1, and a 3i as zeros. Okay? Now, this first guy, again, we're going backwards, so I'm going to write this in factored form. So its matching binomial would be x plus 1. Now, don't get caught up, even though I list -1 again, we can't just disregard it. That just tells me I have another binomial that's x plus 1 as well. And last but not least, this is using that new rule that I just told us. It tells me that I have a 0 of 3i. So I know, just using this one, that I have that as a binomial because I have to have the opposite. But I also know that -3i has to be a 0 as well, which tells me x plus 3i also needs to be a factor. Okay, so when I give you the zeros, you're able to tell me what my factors are. And now we're just going to go backwards. So I'm asking you to find the 4th degree polynomial. Okay, so in other words, I'm giving you the factored form. Our factored form is made up of all the factors that we just identified. So I'm just listing all of the ones that I just found. And now to simplify this, you would have to FOIL all this out. Now this looks way harder than it actually is. Okay? If you follow this rule. If you don't follow this rule, it's going to be a lot harder. Okay? Always FOIL the complex binomials first. Okay? Always FOIL the complex binomials first. If you do that, it'll be a lot easier to simplify this, okay? So let's just FOIL out my blue binomials here. Those are the two with the I in them, okay? So if I FOIL this out, I get x squared plus 3i squared x minus 3ix. Then I get a minus 9i squared. Okay, that's just me FOILing. I'm not even touching the other two yet. Okay, now here's why this becomes a lot easier. Okay, these cancel, right? They're the same, except they have opposite signs in front. So now I just have x squared minus 9, but then what did we talk about way long ago? What is I squared? Yeah, it's -1, okay? So because we FOIL out those complex terms, we get rid of a lot of my variables. So now I have x squared plus 9. Let's bring down the rest that I've ignored thus far. So now this looks a lot easier, okay? Now we FOIL out our nice term. So I've got x squared. This will become a 2x plus 1. And I have an x squared plus 9. And then my last step, I'm going to FOIL this trinomial with the binomial, which just remember, we're just going to give each of these terms to both inside. So I've got x squared times x squared. I'm going to come over here a little bit. Need to make some more room for myself. Okay. So now I'm FOILing this out. So I've got x squared, x to the 4th, because x squared times x squared is x to the 4th. Plus 9x squared. Stay with me, guys. I know we got a couple minutes, but we can finish this. Then I distribute the next term. So I have plus 2x cubed plus 18x. Then I have plus x squared plus 9. Okay? So that's just me FOILing it out. The very last step is we need to put it in standard form. Okay, all of our answers must be in standard form. So I'll have x to the 4th plus 2x cubed. I got to combine some terms here. I got a 9x and just an x squared. So that becomes a 10x squared plus 18x. Oh no, I'm going to run out of room. Plus 9.
There has to be an easier way of doing this.
There's not. There's actually a harder way. All right, that's how we would simplify that one. When you come back in, we'll do the last one, okay? And then we'll do our exit ticket.
Yeah, no.
Okay?
Is the exit ticket the homework?
I think so.
Or is there?
I'll think so. I'll look. I think the exit ticket is the homework today, but we're going off memory.
Isn't it cool that